Okay, this video we are going to introduce what is called the substitution rule. So sometimes when you are trying to evaluate integrals, whether they be definite integrals or indefinite, in this video we're going to focus on indefinite integrals. Sometimes you can't just take the antiderivative of the entire inside of your integral because there are rules that you can't ignore. So the idea here is that we've got some stuff going on the inside, and we have to be able to recognize that we can't just take the antiderivative of each thing inside of there. And then what we're going to do is we're going to make a substitution. And the substitution is we're going to figure out essentially what's going on the inside is we have function composition going on. So we have some function, in this case g, that's being plugged into another function, f. But then we also have the derivative of g inside this integral as well, or some variation of its derivative. And you'll see what I mean by that in just a second. If I recognize that function composition happening, I'm going to make a substitution where I'm going to say, let's let u equal g of x. And if we let u equal g of x, we can replace a function with a single variable called u. And what's going to happen is it's also going to allow us to get rid of the derivative of that function. And so that the integral of f of g of x times g prime of x dx, all of that can simply just be replaced with the integral of f of u du. Okay, so it sounds complicated. So let's look at an example here. I have the integral of 2x times the square root of 1 plus x squared dx. Now, ideally, I would like to change the inside of this so that I don't have a product going on here, right? I've got 2x times this square root. I don't like that because I can't take the antiderivative of each term going backwards if I've got a product going on inside of there. So what's actually happening is we have function composition. We have some function, 1 plus x squared, plugged into a function, the square root function. And so what I want to do is I want to get rid of that. So I'm going to say, let's let u equal 1 plus x squared. Now, not only do we have to say, well, what is that function g, which we just said, hey, it's the thing inside the square root there. It's 1 plus x squared. We also have to be able to identify its derivative. So after I say that, I'm going to say, okay, what is the derivative of u? What is du? So if I were to say, well, u is 1 plus x squared, then du, the derivative of that, the 1 would go away. The derivative of x squared is 2x. But then I have to chain on the derivative of x. So we're just going to say chain on dx. Okay? So when you say, hey, u is this, the next thing you're always going to write down is what is the derivative of that? Du is equal to 2x, and then you're going to chain on that dx part of this. And what that's going to help you see is that not only are we going to get rid of this 1 plus x squared that's inside the square root, but this 2x dx, all of that is going to be replaced with du. So our integral is going to become, so let's think about this. We're replacing the 1 plus x squared with u. So this is the square root of u. And then we're replacing the 2x and the dx with du. So I can get rid of all of that stuff and just say du. And so our integral simply becomes the integral of the square root of u du, which means we get the integral of u to the 1/2 du. And then I'm going to evaluate that. So this is going to become x to the 3/2, 2/3 of that. And then I'm going to make sure I put plus c. Now, normally with indefinite integrals, you're done at that point. However, there's something that we have to be worried about here, and that is that it doesn't make sense to say that the answer to this initial integral, the integral of 2x times the square root of 1 plus x squared dx, is equal to 2/3 of u to the 3/2 plus c. Because what is u, right? We didn't have a u up here to begin with. So this, as an answer to my initial question, doesn't make sense. So the last thing that you are going to do is, after you take the antiderivative, you're going to go back to this, and you are going to resubstitute in for u what we let u be, which was 1 plus x squared. And I'm just replacing the u here with that, and then again plus c. And at that point, we would be done. So essentially what U-substitution allows you to do is it allows you to take some function where if I were to take the derivative of this, I would have to use the chain rule, and it allows us to do that chain rule backwards. Okay, so we're going to need this strategy because we're going to be having some functions here where we have the chain rule going on. We've got to undo that. Okay, if you're not sure if this is the correct answer, take the derivative of this, and you would see that if you did so correctly and using the chain rule, that the derivative is 2x times the square root of 1 plus x squared. Okay, moving on. So, number 2, the integral of x cubed times the cosine of x to the 4th plus 2 dx. All right, so a lot of times there's so much stuff going on inside one of these integrals that you're not really sure what you should let u equal. And again, my best advice for that is figure out what that function is that's being plugged into another function. What is that inside function? And so I just want to let u equal x to the 4th plus 2. That is inside the cosine function. So I'm going to start with, let's let u equal x to the 4th plus 2. The next step I always have to write down is, what is du? What is the derivative of that? Du is 4x cubed dx. Okay, well, what did I have outside of that function that I let u equal? So u was x to the 4th plus 2, and that was plugged into this cosine function. So that's gonna tell me that my integral is going to be the cosine of u. But there was some other stuff inside there. What I had was, I have this x cubed and dx that I need to get rid of. I cannot have u's and x's inside my integral. I've got to get rid of all the x's and replace them with u. X cubed dx. Well, I've got x cubed dx right here. The problem is I have this 4. Right? I've got this 4 right here that was not part of my original integral. So what I'm going to do is I'm going to divide by 4 and basically say that 1/4 of du, well, that's equal to x cubed dx. Right? So what I'm going to do is replace the x cubed and dx not with du, but with 1/4 of du. And when I do that, I can put the constant out front. It does not have to be inside my integral. I can always put a constant out front. So I get 1/4 the integral of the cosine of u du. And now I can go ahead and take the derivative. The 1/4 that's out front stays out front. The antiderivative of cosine of u is the sine of u, and then plus c. And then again, our last step would be to replace u with what u equals, which is x to the 4th plus 2. And that would be our final answer. Okay, moving on. Integral of e to the 5x dx. So what's being plugged into another function? It's that exponent. 5x is replacing just x in that e function. So u is 5x. Du would be 5. The derivative of that is 5 dx. What do I have here? I've got the integral of e to the u, and then I want to replace just dx. That's the only other thing in there, so I need to get rid of that 5. So I'm going to say that 1/5 of du is equal to dx. That allows me to put this 1/5 out front, and here goes du. We have 1/5. The antiderivative of e to the u is e to the u plus c, which means we get 1/5 e to the 5x, plus c. Okay, and last one here. This one's a little bit tricky. Again, hopefully you can recognize what u is, right? So u is the thing inside another function. So in this case, we are going to let u equal 1 minus 4x squared. 1 minus 4x squared. So our derivative du would be negative 8x dx. Okay, so let's think about the integral and what we'd have. Obviously, if we let u equal 1 minus 4x squared, that means on the bottom we have the square root of u. So what is the other stuff that we have going on in our integral? And that is this x dx. Well, here I have x dx. So I'm going to divide by the negative 8 so that I get that negative 1/8 of du is equal to x dx. So I can replace all of that with negative 1/8 du, which means I can put the negative 1/8 out front. I'm going to put the du here. So what do I put on top? I can just put a 1 there. So that becomes negative 1/8, the integral of, I'm going to rewrite this, 1 over the square root of u would be u to the negative 1/2 du. Now I can take my antiderivative, which would be negative 1/8. The antiderivative of this would be add 1 to the exponent, put the reciprocal of that out front, so that's going to be 2u to the 1/2, and then plus c. I'm going to do a couple things at once here. I'm going to go ahead and multiply these constants, so that's going to be negative 1/4, and then I'm also going to replace u with 1 minus 4x squared, and then that's raised to the 1/2 power, and then plus c, and we are done. So U-substitution, it's important whenever you have function composition inside of your integral, essentially undoing the chain rule, going backwards, and we need to be able to recognize that and understand that we cannot take the antiderivative if we have that situation going on. We have to be able to use U-substitution to do that.